All right, I'm here for Lab 4, Fluent project. Let's jump right in. So I have the geometry already set up from the previous uh, labs. So here we are. And for this one, we're using a flat plate in the middle. So go ahead and suppress this, and then go to sketching. All right. And so we're doing a flat plate right in the center. So create a rectangle right here. Go dimensions, change the height or the length. For ours, we're doing with 22.75 centimeters. And for the vertical, ours was 0.25 centimeters. And now we need to measure distance from the center of the plate. So 71, we'll go ahead and change that to 4 centimeters. And we'll take note that there is an offset from the starting line of the plate to the end. So take note of that for later on. And that is about it. So go here, suppress, generate the body. Oh, whoops, I think went back and messed that up. So we'll go back here. There we go. And then we'll generate that. Okay, there we go. That's better. All right, we're ready to go to the meshing. All right, here we go. The first thing we should do is create triangles method. So for geometry, select that, apply, and then go to triangles. Another thing we want to do is go to the sizing and then select the flat plate. All right, apply, and then under element size, go to number of divisions. And for the sake of this video, let's do 100. Capture curvature to no. Behavior hard. Okay, and then go back to the mesh, and we'll do 0.005, just for the sake of the video. And that should be it. So we can generate. Okay. And now we can start naming our sections. So for this lab, we'll name each face of the plate individually. So do internal top, internal bottom, and then we'll name everything else. walls. So the velocity inlet. And then we have the outlets. We have all 7 right here. And that's pretty much good to go. So we can update that. Okay, successful. Close out of this. Go to setup. Okay. And we can see here there's a whole lot more divisions due to the edge sizing we put on the plate, which allows more cleaner calculations in this area, which is what we want for the boundary layer conditions. All right, and so now if you go to models, make sure current model is laminar. And then go to the boundary conditions, go to inlet. For velocity inlet, we set that to just 3.2 for this video. This would be the the inlet velocity at the start right here, the arrows. And now we can set up a new report definition for the coefficient of drag. I already have one here, but I'll create a new one. Drag, and we'll select all the face of the plate. Drag port 2. Okay. Close that. And now we can pretty much start solving it. Initialize it. And then we can run the calculation. 200 iterations is a good amount for just this video. And we can start. Okay. All right. And we need the contours and the velocity contours near the surface of the flat plate. Graphics. I have a velocity set up right here. Display that. And then we can zoom in and we can see right here. So we can see the blue showing the boundary layer. And then we need a velocity vector graph as well. So we can see that here, zoomed in. And now we need the laminar boundary layer velocity profiles at the 3 locations along the flat plate. So we can minimize this for now and go to results. Okay. And we'll create a line, name it first. point. Okay, and this measures from the center to the well, to anywhere in meters. So since the first point we want is at 0.2 centimeters, and um, we also made the distance from the flat plate to the center as 4 centimeters. So we'll do 0.042. Here we go. Do cut, apply, and there we are. There's a first line. Do another second point. And this one is at 8 centimeters. So we will do 2.2. Actually, no, 0.12. This is 4 centimeters plus 8 centimeters. And then the third line. And this one is 0.2. Because so the third location is at 16 centimeters. So it'll be 4 centimeters plus 16. I do cut. Okay, there we are. And then now we need to do a chart for each point. So we'll do first point, boundary layer, location. We'll select the first point. X-axis, we'll do the velocity. And for the y-axis, we'll do y. And we want to create that offset because we already made that offset in the designer of 2.5 millimeters. And then we'll do the bounds of the y to 0.8. And we'll apply that. And we can see the boundary layer for the first point. So let's do the other points. Second point, whoops, second point, boundary layer. And location, second point. And we'll just repeat what we did before. X-axis, y-axis, y. And then 0 to 5. There we go. Oh wait, actually no. We'll do 0.08. Actually, no, the other one looks better. Okay, there we go. There's a third point. And do point boundary layer. Same thing as before. Do x-axis as velocity, and then y. Oh, whoops. I forgot to select that. There we go. And these are all the boundary layers. So that is pretty much it. So you can click export to an Excel file. And now we need to get the wall shear stress. So we'll go back to Fluent. Um, and then go to, let's see, plots. I have X on my plot. So the first thing I want to do is want to change that y-axis function to let's see. Oh, here we go. Wall flux wasn't seeing it. And select the wall shear stress. We do have that. And we'll go to the top of the plate. And then that's pretty much it. And we can display it right here. We can see that shows along the length of the flat plate. So that's working. And now we need the local skin friction coefficient. So to do that, we go same as before, wall fluxes, and instead of wall shear stress, we do skin friction coefficient. And then we can also do that on the top, and we can plot that. And now we have this as well. So we got the skin friction coefficient and the wall shear stress. And now we need to get the drag coefficient. So we'll go up to here, to port 2. But have this set up, can compute, have it right there. We also do for each or for a specific face of the plate. So right now we just did the front, 0.05, on the bottom, etc. And that is pretty much it. Thank you.